Hi everyone, I'm Tamar from Nokia Cloudband, and I'm here to talk to you about the journey towards optimal NFV network performance. So what is network performance and how do we measure it? Do we talk about bit rate, line rate? Actually, what we talk about is the packet rate, packets per second. And this, of course, for different packet sizes provides a different total bit rate, and it is limited by the physical NIC line rate. But as you go down in the packet size, it becomes much more difficult to achieve the actual line rate. Even more important than the packet rate is having no packet drops and having a very stable system to provide to the NFV that does not change over time and provides consistent results in terms of performance. So I set up to measure performance over kilo OpenStack node for OVS and SROV types of VNICs. And I thought that I'm going to just bring up the node, measure the performance, and find the documented rate just popping out of the screen. And it turned out to be slightly different. My first experience after setting up the system was very inconsistent results, packet drops, and very low throughput compared to what I was expecting. So I changed the goal. Instead of measuring the performance, now I have to find the set of configurations to bring me the performance that I wish to provide to the VNFs over OVS and SROV. So I Googled it up, and I found tons of buzzwords that are connected to VM performance. Huge pages, CPU pinning, NUMA awareness, NIC offloading, disable kernel models, so many. What do I start with? I come from embedded background, so I decided to start with CPU pinning. It's easy. So I took my VM and I CPU pinned it. And boom, performance degradation. That was not what I wanted. So I did top, I ran top on my VM and found out a very interesting issue. If you look under the CPU line, right at the end, there's something called steal. Now, when the VM requires CPU and does not get it, that's called steal. Somebody is stealing those pinned CPUs from my VM. Who's doing that? I only have a single VM running on my compute. It has to be the compute. It has to be the kernel of the compute and the packet processing involved with the OVS. So what do? CPU isolation. If you want to use CPU pinning, you must use CPU isolation. You must isolate the CPUs that will provide the kernel and the host processors from the CPUs that will be used by your VMs. Great, now I have my performance is stable again, and I spin another VM to upload the traffic through my OVS, and I made a mistake. I'm sorry, let's go back. I made a mistake. I spinned the VM without CPU pinning. Boom, performance degradation again. Kilo does not protect the users from such mistakes. If you're going to use CPU pinning, you must use CPU isolation, and you must make sure not to use other non-pinned VMs on the same compute. It is your duty as a cloud provider, and it is not protected by the API. So if we look at the components that interact when talking about performance, there are 3 components, and they all must match. There is the network, the traffic characterization, and there is the compute configuration, and there is actually the VM configuration. And there's all sorts of stuff that you can configure here or analyze here. I'm not going to go into this slide right now. I'm going to get back to it later. The 2 most important factors that really increased the performance on my testing were 2. First is the using multiple flows. At the beginning, I started with a single flow, single source UDP, source IP, destination IP, UDP, and I got pretty low capacity, pretty low bit rate and packet rate. Right away, I understood that my flow was not mimicking the real life characterization of the traffic. If I use multiple flows, there are a lot of hardware mechanisms to improve the performance, to utilize more CPUs, and increase the total packet rate for the VNFs. So moving from single flow to multiple flow had a major impact on the performance increase that I was viewing. And then the CPU isolation and CPU pinning that provided stable results not only in terms of network traffic, but it also stabilized the system across using the memory, using Ceph, and other aspects that were not so stable prior to that. And of course, making sure the limitation of not having non-pinned VMs on the same compute. So let's go back to this huge slide with so many aspects that can be configured to improve performance. If we deep dive into it and look at the traffic characterization, once you understand your traffic, how it behaves in terms of the 5-tuple headers of the packet, you can better configure the compute offloading mechanisms to improve the performance. Specifically, if it's TCP or UDP, there are other aspects you can configure when you go into reading the specifics of your physical NIC hardware. Then you go to the compute configuration. You CPU isolate, of course. Some of the VNFs will benefit from having huge pages. And as I said, some NIC offloading features, NIC drivers, making sure you are using the best and the best that are supported. Enabling RX hashing for the utilization of flows per many CPUs. And of course, having the best KVM supported, because the feature set that allow better performance is improving over time. Specifically with Kilo, it is not yet supported, but once you go to Liberty and Mitaka, you can utilize multi-queue functionality and have more CPUs process traffic on a single virtual NIC provided for VM. Talking about the VM, using just any VM will work, you will get traffic. But if you want performance, you must make sure to use the correct drivers that enable you functionality, specifically when you move to SRIOV. Then the enablement of hardware features on the VM side becomes much more important and affects. And of course, then you can deep dive into other aspects like NUMA awareness and further increase the capacity. But as I said, the major increase of the performance was achieved by simply CPU pinning and CPU isolation and combining all the aspects together. So that's what I was going to say. And if you have questions and if we have some time left, I didn't activate the timer, so go ahead. Yes?
You say multiple flows. How many flows did you test up to?
I tested between 10 to 20 flows. It was enough. It depends on how many CPUs you save, specifically with OVS. It depends on how many CPUs you save for the compute. So once you go over and all the CPUs are utilized for the traffic, then there's no more benefit in adding flows.
Did you see any degradation by adding more flows?
No.
Thank you.
Yeah.
You said single flow performance was not very impressive, so can you give an example?
Single flow, the hardware mechanisms make sure that each flow arrives to a single CPU. So actually having a single flow utilizes only a single CPU, and then you get to the max capacity of that CPU. And if you utilize multiple flows, you can get more CPUs working, and that's why you get performance increase. Yes?
What sort of packet rates were you able to?
I'm not going to go into the exact numbers. I can say we reached the documented values. And regarding SRRB, we are still in the process of testing and improving. But I'm not going to dive into the numbers now.
So the single CPU became the gating factor?
I'm sorry, didn't hear
The
it?
single CPU became the gating factor on
CPU utilization is the major bottleneck in terms of performance that we saw. From what we saw. That was the last question. Thank you, everybody. I'm here for additional questions if you'd like. And you can find me on LinkedIn and all the contact details. So.